So in question 4, we were asked to prove this sum of n term formula, okay, that the sum of the first n terms is this. So let's go about it, and the first thing I would do here is put a little statement and say, look, let Sn, okay, represent or be the sum of the first n terms of an arithmetic progression, okay, an AP. If you think about it, the sum of the first n terms, well, the first term will be a, won't it? Okay, if you think about it, the first term is a, and then the second term will be a plus the difference. Yeah? Okay, that's the first term there, and to get the second term, you just add the difference onto the first term. Okay, and so on. I mean, the third term will be a plus twice the difference. Fourth term will be a plus 3 times the difference, and so on. So I'm not going to write all them down. Okay, I'm going to just put blanks there to represent that. Okay, but what I'm going to do is write down the last 2 terms then. Okay, so we know that the last term is this, the nth term is this. So the one before it will just be n minus 2 in there. Okay, so you'll have a plus n minus 2d. And then the very last one then is what we know is the nth term, a plus n minus 1d. So then with this process, what you do is you write down the whole thing again, but you reverse the order of it. Okay, so you put the nth term, the last term, at the beginning here, directly underneath this a, right? So a plus n minus 1d, okay? Plus then, underneath the second term then, you write the last but one term, because you're reversing the order, a plus n minus 2d, plus dot 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 plus, and then you get then to the last 2 terms here. So underneath them, you're going to write the first 2 terms, because remember, now reverse the order. So we're going to have the second term here, a plus d, and then we're going to have the first term then at the end. Okay, so I've written the same thing essentially, but reverse the order of it. And what you do then is you add, okay, you literally add these 2 SNs here, okay. And if you've got them lined up properly, then something magical happens. Okay, so if I add them, Sn plus Sn is 2Sn. If I add the first term here to the last term, well, if you think about it, the first term to the last term, well, a plus a is 2a. Okay, and plus then this n minus 1d. And what you'll find, when I add the second term to the last but one term, that will also add up to 2a plus, well, d and n minus 2d will give me n minus 1d. Okay, so we've got 2a plus n minus 1d plus 2a plus n minus 1d plus dot 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 plus, here a plus a is 2a, n minus 2d plus d is n minus 1d. Plus then at the end, the last term here, add to the first term, it would be 2a plus n minus 1d. So what you've got here, all the terms are 2a plus n minus 1d. They're all 2a plus n minus 1d. And of course we've got n of them, haven't we? Because we had n terms to begin with. So I can rewrite this and say, look, 2Sn, well, I've got n of these, so that's the same as n lots of, okay, n times 2a plus n minus 1d. N lots of them. And quite simply then, you just got to divide by that 2, and you get the Sn that we know. Okay, that's written in the formula booklet. And we proved the sum of the Sn terms is n over 2 bracket 2a plus n minus 1d close bracket.